Copper crystallizes in a face-centered cubic unit cell with an edge length of 362 picometers. What is the density of copper? So to start this problem off, I'm just going to set up the general formula that we're going to use. We know that we need to find the density, and our density is just going to be our mass over our volume, which for a cubic unit cell has a very helpful formula, which is N, representing our number of atoms, times A, our molar mass, over the volume of our unit cell, times Avogadro's number. And this is the same thing as mass over volume because this term here ends up being our mass because we have some number of atoms and we're dividing by Avogadro's number. So we have 1 mole is 6.022 times 10 to the 23rd atoms. Our atoms units end up canceling. And then when we multiply by our molar mass, we end up having some number that represents our molar mass in units of grams per mole. Mole will cancel, and we're just going to end up with units of grams and get our mass. So that's where that formula comes from. And now that we've done that, I'm going to find the volume. And because we have a cubic unit cell, our volume is just going to be our edge length cubed. Sometimes people represent that by A, sometimes by L. So to do this, I want to convert our 362 picometers to centimeters. I just find that most of the time the density is given in grams per centimeter cubed for cubic unit cells. And when you have this in a multiple choice format, based on the units given in the answers, you will know what to convert to. So we have 362 picometers as our edge length. And then to convert that to meters, I know that for every 1 picometer we have 1 times 10 to the negative 12 meters. And conversions like these are really helpful to memorize for the exam if you're not given them. And then from meters, I'm going to convert back to centimeters because for every 1 meter, I have 100 centimeters. And the reason I'm converting from picometer to meter and then back to centimeters is because usually when I try to do it all in one step, I end up messing up somewhere. So this is really helpful for me. So I end up getting that this is 3.62 times 10 to the negative 8 centimeters. So now we can find our volume, which is just 3.62 times 10 to the negative 8 centimeters cubed, which I ended up getting 4.744 times 10 to the negative 23rd centimeters cubed. Now that we have our volume, I'm going to find the number of atoms. And the number of atoms in a cubic unit cell is based on the type of unit cell. So in our case, we're given that this is a face-centered cubic unit cell. It can be face-centered, body-centered, or simple cubic. So that will tell us information about the number of atoms. And I'm going to attempt to draw this to show you, although I'm not a good artist. So we have our unit cell, and for each corner we have 1 atom, and then for each face we're going to also have 1 atom on each face, which is going to look something like this. So now that we have that drawing, we can look at how many unit cells are sharing each of these atoms, and that is how we'll find the number of atoms within this cell. So for our 8 corner atoms, these are being shared by 8 other cubic unit cells. And so that means that only 1/8 of that atom is actually in this cell. Then we know that we have 6 atoms on every face, which, sorry, is a little bit hard to draw for me. And we know that each atom on each face only has 1/2 of it in this unit cell. So if you can imagine another unit cell sitting right next to this one and touching, this atom on the face is being shared by those 2 unit cells. So 1/2 is in this cell, 1/2 will be in this cell right here, if you can picture that. So using this formula, we get that in total we have 4 atoms. And now that we've done that, I'm going to find the mass. So as I was describing earlier, we can take the number of atoms and divide by Avogadro's number. And we're going to get moles, which will be 6.64 times 10 to the negative 24 moles. And now that we have that, we can find grams based on the molar mass. And in this case, we need to look up the molar mass of copper. And now I can get our mass in grams, which will be 4.22 times 10 to the negative 22 grams. And so the last thing I'm going to do is find the density that we're asked for. So the density is just going to equal the mass that we found, which is 4.22 times 10 to the negative 22 grams, over the volume that we found, which is 4.744 times 10 to the negative 23 centimeter cubed. And I get that this density is 8.9 grams per centimeter cubed.